In this video, we're going to look at how to simplify rational expressions. So in this first example, we have 5x squared divided by 10x. Because we're dividing, we can cancel some of the common terms. Now, I want to look at this example, or use this example to look at what's really going on when we cancel terms. So what I'm going to do is break this apart by essentially kind of unmultiplying the two fractions here. I'm going to break it apart into 5/10 times x squared divided by x. Okay, I'm unmultiplying. If you were to multiply these two fractions, you would multiply the numerators together to get 5x squared, and you'd multiply the denominators together to get 10x, so you'd get this. Okay, 5/10 reduces to 1/2. Now x squared over x, I'm going to break that up even further into x over x times x over 1. Okay, I'm doing that because I want to illustrate this right here. X divided by x is equal to 1 because anything divided by itself is 1. So when you cancel two common factors, what you're really doing is pulling off or unmultiplying a factor of that over itself and saying, well, that equals 1, therefore we're just not going to write it. So what we're left with is 1/2 times x over 1, which when we multiply together, the numerators and denominators, we get x over 2. Now the more common way that people would probably write this is they would do 5 over 10 and put a 2 there, and the x squared over x, they might cross out that square and cross out that x. So what that leaves you with in the numerator is that x, and in the denominator is that 2. Okay, and the next example, what you don't want to do is expand first. You always want to factor first, cancel common factors, and then, if needed, expand. And by expand, I mean FOIL. So what we want to do is cancel factors. Okay, it's already factored. We have 2 factors in the numerator and 2 in the denominator. You can only cancel factors, common factors in a fraction, if both the numerator and denominator are completely factored. They've got to be completely factored. And this one it is, and it was also in this example. I'll show you one where it's not factored in just a moment. And because there's an x plus 3 both on the numerator and denominator, those are going to cancel. Okay? They're not in the same position. You could easily reverse those two around if you wanted to, but it's really unnecessary. And that leaves us with x minus 5 over x minus 2. Now this is not, it's no longer factored because of this minus sign. We have 2 terms in the numerator separated by a minus, and 2 terms in the denominator separated by a minus. So my point is that it would be incorrect to then try to cancel the x's. Okay, so if you were to try this and say, I'm going to cancel those x's, you would be left with negative 5 over negative 2. Your negatives would cancel, so you'd be left with 5/2. In reality, let's plug in an x value here. Let's just plug in 1. I'm going to plug it into that. So I would get 1 minus 5 divided by 1 minus 2, which is negative 4 over negative 1, or positive 4, which is definitely not equal, okay, to 5/2. So hopefully that illustrates pretty clearly why you cannot cancel factors, or you cannot cancel terms. You can only cancel common factors. Everything has to be factored in both the numerator and denominator, so that you could do this and pull that factor off as if you're unmultiplying it, so that it's something else times your factor over your factor, so that it equals 1. Okay, and the next example, as it's written, there's nothing you can do. You can't factor, and I recommend pausing here, okay, and attempting the next 2 on your own first. Okay, let's look at it though. Can we factor? Well, in the numerator, we have 2x plus 14. 2x and 14 have a common factor of 2, So I could take a 2 out. That would leave me with x plus 7. All divided by x plus 7. So now the common factors of x plus 7, because they're exactly the same, do in fact cancel, because you could pull that off like this, right, as a factor of 1. And so we're simply left with 2. And in this last example, it's not factored, but we can see if that denominator will factor. So 2x squared plus 11x minus 21. I'm going to set up a product of two binomials here. Let's see, one of the first terms is going to have to be 2x and the other is going to have to be x for them to multiply nicely to 2x squared. Let's see, we have a minus 21 out here. I'm just going to use the guess and check method here to figure out how to factor 21. I'm going to go with a 7 and a 3. That's really the only two factors of 21. So the question is where to put the 7 and where to put the 3. Let's see, I'm going to try putting the 7 there and the 3 there. Okay, let's see if that works. Now what signs do we need? They have to add to a positive number and multiply to a negative number. So one of them's got to have a plus sign between the two terms and one's got to have a minus sign. So let's just give that a try. So now what I'm going to do is FOIL that denominator to check. So my 2x times x for my first terms, that's 2x squared. I know that one works. Now here's the part we're working on, is the outside and the inside terms. My outside term is 2x times negative 3 or minus 6x, and my inside term is positive 7 times x or plus 7x. And my last term is 7 times negative 3, which is negative 21. So the negative 6x plus 7x combines to positive 1x, not 11x, which is what we want. So that did not work. Okay, I'm going to delete that. Let's go back here. Let's see, I had the 7 there and the 3 there. Let's try reversing them. Let's try putting the 7 and the 3. And I like this because what I'm kind of doing in my head is, okay, that's a 14 and that's a 3, and I can combine 14 and 3 in such a way so as to get 11. Okay, so to do that, I will need to make the 14x positive. So I'm going to put a positive sign there and a minus sign there. Okay, again, let's do it down here. FOIL to check. I know my first term is correct and my last term is correct, so I'm just going to do the outside and the inside here, OI. My outside term is positive 14x. My inside term, negative 3 times x, does equal 11x. Okay, so when we FOIL that out, we get this back. Okay, now that it's factored, we can look for common factors. And 2x minus 3 happens to be a factor, both on the numerator and denominator, so that cancels. And anytime you cancel all of the factors out from either the numerator or the denominator, you're left with a factor of 1. Because you could always put times 1 there. Okay. Oops. So it equals 1 over this factor, x plus 7. That's not going to simplify any further. Let's look at one last example. This one involves a little technique. Okay, so 7 times x minus 5 over 5 minus x. So when you look at this, you probably notice x minus 5 looks a lot like 5 minus x, but they're just slightly different. So we need to make them look the same so that we can cancel them. And the way you do that is if you have like a minus b and b minus a, and they're almost the same, but the order is switched. Okay, the order of the x minus 5 is reversed from the 5 minus x. And if you're subtracting, this only works if you're subtracting. The technique is to factor out a negative 1 from one of the factors. So I'm going to factor it out from the denominator in this case just because it's a little bit simpler. So the numerator I'm going to copy, 7 times x minus 5. Now I'm going to factor a negative out from both terms. If I factor a negative 1 out from positive 5, I'm left with negative 5. And then negative from negative x leaves me with positive x. Again, I'm going to recopy the numerator. And now these terms are actually the same because the order of addition doesn't matter. So I'm going to reverse those two terms to make this a little bit more clear. This negative that we factored out still hangs out up front. Negative 5 plus x is the same as x minus 5, positive x minus 5. And now the factors are the same. So we have 7 divided by negative 1, or negative 7. And that's it for this section on simplifying rational expressions.